And so it is. So we're doing DOM calculator review. We're writing some tests. I disabled like 3 things on my computer, so hopefully we can get through without my computer catching on fire this time. So really we want to click on the thing that says 1. We want to click on the thing that says plus. We want to click on the thing that says 1. And then we want to click on the thing that says equals. So these are the actions that we want to take. Let's see. So in testing parlance, we could say that's setting up the state of the app. We're just going to the web page. We are taking these actions, and then we want to assert something that's the case about the app. So what am I asserting?
1 + 1 = 2.
Yep, but like from the perspective of the user, how does the user know that this generated 2?
The screen of the calculator should result in 2.
There we go. So I should be able to find some DOM element that has that in it.
ID of screen.
Yeah. And that's what it's called, right? Yeah, screen. So I should be able to get that container. And it should have text 2. Something like that. That would give me some confidence that my app works correctly. So I go over to my test runner. Oop. Sci.visit, how about? All right, so I was able to do the first parts, and look, it worked correctly, but it's one of the reasons that people people don't like tests is like, it works correct. How do I write the fucking test so that it understands that? All right, so I was expecting it to have the text of 2, but the text was nothing. So I'm going to element inspect that. Ah, it's an input. Does anybody know why the text for it isn't 2?
Is it a value instead of an text?
It's value, not text. Should. Expect it to have attribute value. I'm pretty sure that's how the syntax for that works. Cypress test input value. Input should have value. Ah, there we go. It's not have adder. All right. There we go. There's a green test. So I can do that one. Arrange, act, assert. That's the shape of like most tests. We could say a more complicated one. We could have adds 8, adds 9, and 8, and 7. So it goes to the site, and it clicks 9, and 8, and 7. One of the things that's kind of cool about, these are called characterization tests, where the app is already built. We're just adding the tests afterwards. Is that like, oh no, my stupid brain, I can't figure out what all those things together are. So I just make something up. And it's going to go, it's not too stupid, it's 24. It's like, there we go, thank you. All right, so I got 2 green tests. And then I could do something like division. We won't do it for all of them, just a couple. So we could say it divides 6 by 3. So we go to the site, 6, 3, except we don't want the plus sign, we want that goofy little Unicode character. So easiest way to do that is just
I have it set up to be the, never mind.
We can just copy that little Unicode character in there. And did it work? Hey! Then let's get 1 for multiplication. It multiplies 4 by 5. So we can say 4, 5 equals, is that an X that we're using there?
Yes.
Yep. Cool, we got 20. And one last one, we'll throw one in for subtraction. It subtracts 7 from 9. So we'll say 9 minus 7 equals 2. You're beautiful. Cool. So like we have some tests, and so as we start mangling this code, this is our safety net. This is how we know what we broke, how we broke it, and what have you. Cool. So we're going to shift our attention over to this code. So first thing that I do when I'm looking at something like this is I go, all right, is there anything like obviously wrong? I have some ideas about how that could be done. All right. Anything that's like just right off the bat kind of fucky. Okay. Like, I don't like the formatting on this. I can't really figure out what it's doing. So, all right, I get what that does. Like commented out code. I don't care about commented out code. Get rid of it. Okay. Those should be there. Console logs, don't need them. Console logs, hate them. Okay, so all in all, that's not too bad. And one of the things I really like about Logan's code is how small these functions are. Little teeny bitsy functions. Really easy to read them. It's going to be easy to change them also. Okay, so next thing that I look for is any really low-hanging fruit in this. So like other ones on line 39, we have some trailing white space. There it is. We got some more on line 42. We got some more on line 61. Got some more on line 63. All right, our trailing white space is gone. Any like super low hanging fruit. So one that occurs to me is I always get a little bit itchy anytime I see something like this. Anytime I'm doing almost exactly the same thing a bunch of times in a row, something about that doesn't sit right with me. So one of the ways that we can clean that up is if we throw it in an object. Because those things are all like, have some relationship with each other. They're all DOM elements. So what if I copy this over and I do something like, maybe I make the variable called $, and I set it equal to something like that. So I get rid of all those scope operators. I get rid of all of these. I'm going to change the equals to colon on those. I'm going to add commas and close it up. So now it's going to end up working almost the exact same way. I'm going to do $dot numbers, but instead of $numbers, but by throwing these all in a container, I'm kind of hinting to the next person that these things, they got some kind of relationship. This is going to be like a little box that I can look up elements in. So to start using those, I want to look for each time that like that's getting used and change that to $dot numbers. Cool. So now I should be able to get rid of that and without breaking my tests. There we go. Cool, didn't break anything. So the next one, $operators. Okay, make it dot operators. That looks like that's it. So if I get rid of that, oh baby, equals. Cool, and that's it. So I should be able to get rid of that. Didn't break anything. So if I look for clear, $dot clear, that's it. Very nice. And lastly, screen. A couple places we're using this. So I should be able to get rid of that now. And the tests all still work. Hell yeah. So, like I said, I'd call that low-hanging fruit. We don't have to really like untangle the code too much to do that. Let's look at some more. Anytime that I see something like this, where I have a function that I'm declaring, but all it does is like, and then I immediately run it, and that's kind of the only purpose of that. There's a better way to do that called an IFI. This is classic Mod 3 material. An IFI is, I don't see them as much in JavaScript anymore. It stands for immediately invoked function expression. So instead of doing this as two steps where we declare a function and then just immediately invoke it, we can actually do that as one step. So the trick is you wrap that in parentheses, you invoke it, and then you put any legal JavaScript character in front of it. It's kind of fucked up. It's hacky how that works. But sometimes when you look at minified code, you'll see it that way. But if I do that, I should be able to do something like that. Let's see if it works. Still works. Yeah. Ah! So sometimes that's with like an exclamation point. It can also be a tilde. It can be a couple of other things. but it's just not the letter F. It's basically the criteria on that. IFEs, these are called. Questions?
Would it be better to not use an exclamation point since that frequently references not? Or does that not really apply for IFEs?
Doesn't really apply for IFEs. Like, this pattern looks weird enough that if you've never seen it before, you won't be able to figure it out anyway. If you have seen it before, question or exclamation point is like the canonical default for doing an IFE.
Did you say you're seeing it less in the JavaScript community?
Mm-hmm. Because there aren't all that many vanilla JavaScript apps anymore, and you almost never need to do these with something that uses modules. Like, there's not a whole lot of good reasons to do that in a React app or a Vue app or something like that. Vanilla JavaScript, though, definitely. There's just less vanilla JavaScript out there. Another thing, this is getting like a little precious, but it's that same sort of thing where I was like, all right, I got 4 functions, but all I do is just call each one after the other. So that's 4 statements. That makes me itchy. 4 almost identical statements in a row. So what I would probably do is something like, instead of invoking each of those, throw them in an array like that, and then each over them. We can't use function like that because that's a reserved word. So that's where like FN, it's like one of the few places where that actually applies. Actually, I don't even think you need the call. I think you can just do something like that. Call makes it a little bit clearer what you're doing though. That's one statement. And I think it makes it a little bit more clear what your intention is. And if we need to, we can reorder these by like just like that. That's a little precious, but that is probably what I would do if it were my code. Questions about that? Most important question, did I break the code? Nope, doesn't appear to be. Cool. Let's see.
Does doing anything like that help with performance, or is that just for like readability and modification? So like if you needed to add another function, you could just easily put that in that for each, and it's so easy.
Definitely. Nothing we've done so far has any positive effect on performance. This is just for readability. And one of the things that I'm hoping we'll see as we work through this, every student's code is different. We might see some opportunities where we're doing essentially the same thing. And that only becomes obvious when we start applying some of these patterns. And we go, ah, these are really the same thing. That means I can make them the same function or something like that. Logan's got pretty terse code here, so I don't expect we'll see a ton of them, but who knows? Might be surprised yet. All right, numbers to screen. So we go through each of the numbers. Very good use of this CSS selector. Every span that isn't an operator. Nice. Also very good use of multiple not pseudo selectors. Logan, I think you're going places. So have these numbers. For each one of them, I want to add an event listener. It's a click listener that add number interaction. So I'm a little bit anxious about the word add, because what Logan means is that whatever just happened, we want to put that on the screen. The reason I don't like the word add here is add is also one of the operations that we're doing. There's this term called ubiquitous language. It's from a programming book called Domain-Driven Design. The idea behind ubiquitous language is that you want the same word to mean the same thing every single place you use it in your app. So if we're using add to mean summing two numbers together anywhere in the app, we want that to be the only thing that add means. So what else could I do that would be a synonym, mean the same thing? What else could I call that?
Show.
Show, like show number interaction? Maybe. So if I do that, that works. That's a little bit better. But one of the challenges with show is I'm not communicating very well that this is cumulative. It's adding it to what I already have.
Append.
I like append. Append number interaction. Okay, the next gripe I'm going to have with this is I don't think we need the word interaction. If I take the word interaction off, it kind of means the same thing. In fact, it's a little bit clearer that I'm appending a number. Now, what I might do to clarify this is append number to screen. That's not too bad. One more gripe with this. So we're calling this function append number to screen now. So if you couldn't see the code at all, what would you expect it takes in?
A number.
A number. What does it actually take in?
User clicking a button.
Yeah, that event of the user clicking the button. So what I would do here is try to separate out that number from this function. So rather than that function taking in the event, we got to find a way to just get it the number. So a way to do that is to kind of chain this on down. So we can say something like that. And now this becomes number. And look how much simpler we've made that function. We've moved that complexity over here. You can't get rid of complexity in an app. You can just move it around. Ideally, you're moving it into the language or into the framework or something that's hidden away from you. But in this case, we're moving the complexity to something that feels more related to me. We're keeping everything that's talking about events and what have you with all the event code. It feels a little bit better. My next gripe. You know what grinds my gears? So we're calling this function numbers to screen. It's not really what's happening here, though. What's actually happening?
Adding events.
Yeah, oh, adding event.
listeners.
Adding event listeners. So might call this like attach number listeners. I feel okay about that. And I got to make sure that I change it here too. A lot of refactoring is just this. It's really like thinking hard about your names and seeing if you can come up with better ones. 9 times out of 10, when I'm like trying to debug student code, the names are terrible. And that's the problem. Because it starts messing with how you think about these problems. You start using the wrong word for something, or no, it's just a placeholder. I'm gonna get back to it later. And all of a sudden you start thinking that that thing really does take in a number when it actually takes in an event. Sweating those details makes your debugging easier. Okay. Onward. That's good. This line's getting a little bit long. That's 95 columns long. You try to keep it under 80 wherever you can. So while I love the one-lininess of that, we're probably better off breaking that up. And now the longest part of it is 63 columns. It's a little bit better. So we go through each of the operators, and then we got the same thing going on. And we do it the same way. So I'm also going to bust out the number from the event. Do it the same way. The only place it is, yeah. And so now that becomes number. A good hint that like this is the thing that you should do is that the only thing that we're doing with event is grabbing its .target.text content. That's the thing we should actually be passing into the function to begin with. You want each function to only have like the very few things that it needs to run, rather than passing around these giant fucking objects everywhere. So if I do that, I can make that number. I can make that number. Oop, it says operator. Good call. And in the process, we've also made this code easier to understand. I can figure out what's happening in that function a lot better than when it looked like that. I see that, I gotta think about it for a while. I do that, makes more sense. Similarly, I'm gonna call that append operator to screen. Append operator to screen. Cool. And then similarly, we call these attach number listeners. We can say attach operator listeners. And now we're starting to get a sense of how Logan's solution to this problem is like starting to come together. All right. So we've got some symmetry there between those two. And if we're looking at this, all right, so now I want to start actually like changing a little bit of code implementation. So switches are totally fine for problem solving. They're one of the first things I get rid of. Anytime I'm refactoring code, switches are number one. Number two is if statements. If I can find a way to get rid of an if statement, by God, I'm going to do it. I gave a talk a few months, might be a year ago at this point, about this very concept. It's on my website, and it is called Programming Without Ifs. There's a recording of it if you want to watch it, but it's about how we get rid of conditional logic in our code, because conditional logic is almost always the problem. So how might we do such a thing? How do I get, so like, first of all, the TLDR problem with this is there are so many different paths through this code. We've got 13 lines of code here. And so operator comes in 1, 2, 3, 4, and there's even a hidden one. What's the hidden one?
Default.
Default. We're not explicitly declaring a default, but that is a potential pathway through the code, is that it doesn't hit any of these. So in 13 lines of code, there are 5 different paths through it. So to get confidence that this does what we think it does, we need to write 5 tests for it. Yowza. Also, Logan's taking advantage of a fall through here, where if it's either of these, then this is the behavior we want to do. So this turns into something where like the order can become important on this. Like when you have switch statements, you switch the cases around, there's a fall through somewhere. These are really easy things to miss. So we can change this code so there's only one path through it. Radically improves what we call the complexity of the code, cyclomatic complexity. Cyclomatic complexity is how many different paths are there through something. So what we do is we try to take this conditional logic and we try to turn it into data. Here's how. Let's say we make an object called operations. And what we're going to do is we're going to make keys for each of these. So we'll have plus as one of our operations. And what we want to come back from that is this operation. So we're going to set it equal to a function that does this. Now, if I want the behavior that I have up there, I can do operations and then invoke it like that. This is called dynamic dispatch. Does the exact same thing as the conditional logic, but instead of conditional logic, we're looking it up in this object. As I add each of these different behaviors here, those aren't different, baby, shh. These aren't different paths through the code. There's only one path through the code. Different keys in an object isn't a different path. We've turned the conditional logic into data. This is probably one of the most advanced programming patterns that I talk about in the program. But like, this will make your code better. So we also had this with minus. Let's see. Have this X here. And then one for divide. Take a look at that for a little bit. I'm looking up what the operator is and invoking it. To improve clarity on this, I would just write these out. That makes it a little bit easier to follow what's going on.
And are you leaving those functions on separate lines just because it's easier to pull it out?
Well, so we could jam it all into one line, and I actually don't hate that with this, since there is like so much repetition in it. But like sort of gets a little bit gnarly. We can actually take advantage of a really cool JavaScript syntax thing. It's kind of new. Instead of, anytime you're doing this, you can rewrite it as that. It's the exact same thing. And that, I think, actually works pretty well on one line. Like that. So if I take out those functions, like that, I don't mind that. This is a very good example, though, of like, as we start refactoring stuff like this, we start seeing some patterns. There's a lot of repetition in this. What's being repeated?
Screen.value.
Plus equals. We're always appending this thing to the screen, right? So I wonder if there's a way to yank this out. Because why do these things, why do we need to do all of this shit to begin with?
Just add it to the screen.
We're adding it to the screen, but why can't we just do screen.value plus equals operator? What would be so bad about call it a day?
Is it because he's changing like the X to the like the star?
Yeah. The X becomes the asterisk, the division symbol becomes slash, because we can't evaluate the division symbol. JavaScript doesn't know what that is. Have to have like an actual operation. So what we're really doing is we're mapping symbols, one representation to another representation. What we've done is we've combined that. We're looking up the symbol and doing the operation with it at the same time. That's a mighty fine refactoring opportunity. So, so what if we did this? We had operators, and then maybe we call the thing that we're passing in like a screen operator, displayed operator. I guess the one on the calculator is the operator, and then we'll make a displayed operator like that. So this one, it's actually a lot simpler than that. So this one, we can go, well, those are just the same. And that one's that, and that one's that. Cool. So we just have like a little lookup table. And that's what this pattern is called. A dictionary lookup. So with dynamic dispatch, we were doing that. With this, we can get our operations. We can look up the operator or displayed operators, plural. We can look up that operator. And now we can do $.screen.value plus equals that. Now we've removed the repetition. So take a look at the journey we went through here. Here's the conditional logic. It's got 5 different paths to the code. One of them's hidden. All of it is order dependent. So we turned those into data. But in doing so, we noticed that we had all this repetition. So we found a way to get that out of there by only doing the operation once and then looking up the symbol every time. So now, whew, that's beauty. And there's only one path through this code. Declares the variable, and ta-da, done. Ask me some questions about that. It's like the gnarliest thing we've done in the program.
So you said you never use ifs or switches or like conditional
I
things.
didn't say never.
You tried that.
They give me hives and I try to get rid of them.
So do you feel like usually you can switch it into some kind of object that you look at? Is that how you normally? Okay.
Absolutely. So there's a bunch of different techniques for it. I go over a bunch of them in that talk. Sometimes you can't get away from it, but you can more times than you might think. In an object-oriented language, you can use some subclassing tricks to get rid of conditionals. So rather than having conditional logic, they're just different subclasses of the same class, like the one where it worked and the one where it didn't. You can use this dictionary lookup technique. You can use the dynamic dispatch technique. You usually have a few different options for getting rid of a conditional, or rather turning the conditional into some kind of data. More questions about this? Cool. Onward. Calculation to screen. So whenever whenever the equal sign is clicked, call this return value. And then, we add a key up listener. Ah, I see. So we've got 2 different listeners, one for the equals button, one for the key up for enter. And if either of those are called, we invoke the return value. I'm also inclined to see if there's a way to make it more clear. That those are both essentially the same thing. one of the things is we can fix the names, because this is really attaching equals event listeners. So we're only doing those two things there. So we'll say attach equals listeners. Change that there as well. We've changed a whole lot of shit. We should check our tests. Still good? Still good. Okay, so we're attaching equals listeners. Return value. Not wild about that name either. Let's take a look at what it's doing. It takes the value of the screen. It generates a result with eval. It writes something to the screen, writes error to the screen if either of those two things happen. Otherwise, it displays it. Okay? Start with a name. Help me think of a better name for return value.
Render total to screen.
Ooh, I like that. So, one of the cool things about this process, a render total to screen, where else could we render something? I can't think of one. So like a lot of this, if you ever did any like creative writing or revising or something, that's what this process is. We're trying to figure out how we can communicate something densely and concisely. Render total feels pretty good to me. You could make a fair case that calculating the total and rendering the total should be two different steps. So I'm kind of inclined to split that out. And do something like that. Because, and here's the reason why. There's a few different ways we could do this. Eval is probably the least safe. You'll see different blog posts called eval is evil. There's problems with it. It's a big threat vector. People can attack your site when you use eval. It's fine for this exercise. But that's not the only way we could do this calculation. So if we have this split out into its own function, one of these days when we change it from eval to something else, all we're changing is this function, not things that use this function. So then this becomes, maybe we do something like render total and pass in calculate total, like that. And now this takes in a total. Yeah. That looks mighty fine to me. Okay. Ooh, here's a good opportunity. So let's say I want to keep the conditional in this. What's the repetition that's happening in this function body?
What the value of screen total or screen is.
Yeah, we're doing that assignment in both of those. Anytime you see that, that is a real good opportunity to use a ternary. So I can use $.screen equals, and then I can take this conditional up here, pop that onto the end, and then if that's true, we want it to say error. And if it's false, we want it to be total. That turns into that with the ternary. A lot cleaner. You could even one-line that pretty well. I don't hate that. I always prefer my ternaries on multiple lines like that. There's style guides that super disagree with me. It's a relatively controversial thing. I'd say 60% of JavaScript developers disagree with me on this, but I think that's easier to read. That's not terrible though. Oh man, strictly speaking, we don't even need the parentheses anymore. Do we break the code? God, we just can't do it. All right. What else do we have? Okay, just two more functions. So clear screen adds this click listener. But again, it's not actually, well, clear screen, I would expect to be something like $.screen.value equals, that's what I expect clear screen to be. Really, this is attach clear screen, and press clear listener. Yeah, something kind of like that. And then, oh man, what's happening here?
So that one specifically is the extended challenge was to take keyboard inputs, and I was trying to keep eval from breaking because it's evil, but I couldn't find anything after like an hour of Googling of how other ways to do it.
All right, so we have code here that's not doing anything. Yep, it's not being used anywhere, so we get rid of it. Cool. All right, so that's our first pass through this. We've like cleaned up some low-hanging fruit. We've cleaned up some medium-hanging fruit. But this is an iterative process. These allowed characters then probably aren't getting used anywhere also. So we'll get rid of them for now. All right, so we've got that. We have this iffy. All this is doing is attaching listeners. Curious. Oh, this is starting to clean up okay. That's starting to look like pro code. Ooh, here's another opportunity. Since calculate total is getting invoked in both of those, that means total should go there. So then this can be like that. Gets used either way. So it should probably be that one. Ooh, actually, I don't think that'll work. No, it totally won't. Nope. I'll bet that breaks it. that should break it. Weird. Why would that still work? And the reason why I'm wondering about this is because I've actually changed how total is calculated on this. I've made it so that the, well, actually, you tell me. What's kind of funny about how I changed how total is being calculated? It's a scoping thing.
You invoked it when you did the total equals and then put that amount in. So hypothetically, it should be the total that you have for your constant should be the total at the time that the event listener was added.
Correct. Actually, I'll bet if I go back and run this again, I'll bet it gets mad at me. Yep. No go, buddy. Whole bunch of failing tests. It's because it's happening. This little callback function here, that function runs every time. And we want it to run every time separately.
Could you do total equals whatever it was without invoking it and then do total invoke?
Yeah, like, I don't know that that's saving anything at that point. Oops, it's mad at me about something else. It does want the parentheses on this.
I think you left off the dot value after screen.
Oh, yes, I did. Good catch. There we go. Back in flavor country. Oops. Good catch. Thanks for saving our asses, test. So, can't subtract 7 from 9.
It's in that dictionary, looked up dictionary thing you made.
Nice. You're beautiful. See how tests save your ass, man? If I was just doing all this stuff by hand, no way I'm going to catch that one. There we go. Ask me some questions.
How much time should we devote to making those tests?
Well, take a look at, like, you guys saw me make these. How much time did I spend on it? Like, almost all this was copy paste. I probably got these tests written in under 5 minutes. It's a pretty big payoff. One of the reasons we don't emphasize testing quite as much in this program is writing tests is easy. Like this syntax you're seeing, like 90% of testing syntax is it's describes and its and like a couple sci commands. Knowing what to test, yeah, it's a little bit trickier. Writing meaningful tests, that takes some practice. Like, I really liked how Alexander Tarlander, who had a really great book called Developer Testing, actually I have it right here. This book. he said that like, before you start trying to get good at writing tests, write a lot of really bad code. It's legit, like, probably the right place to start. I'd say like, you guys are probably scratching at like about the right time to start learning testing. If you don't do any of it until after the program, that's okay too. But where I would start with testing is with these Cypress tests. All you have to do is, what would you do with the app to give you some confidence that it worked? Like, what are you doing by hand right now? And you're like, well, I click on this link and then this screen shows up and this thing should be on the screen. And when I type this thing in the form and then I hit enter, the following shit should happen. Cool. You can write almost in that language Cypress tests like that. And all it does is just automate that for you, so you don't have to do it by hand every time. That's all you do for testing. You are already like in an upper echelon of developers. There's a lot more to like testing philosophy, and if we were writing this from scratch with tests, I'd probably BDD it. So we'd write little tests for each of the smaller functions as we were going. But good place to start with testing. What would you do that would make you think that the thing works? Write a little script for that. More questions?
What are some things we can do outside of eval?
Ooh, so if I can't just take the thing that I'm given and evaluate it, what else could I do? I'm not going to make you write it out, but like, think through the logic. If you had to write a calculator that like performed calculations by hand, like what would be some examples of the things that it could do? What if you split each of the characters that's been entered? Actually, shoot. What if the thing that was being displayed was just a visual representation of an array of each thing that's been pressed? That's your first hint. So if I have 34 plus 57 equals whatever, it's 5, 4 plus 3, 7. So I have each of those as items in an array. If I just gave you that, what could you do to perform the calculation? What if you shift off the first part of the array, and then you take a look at the next thing at the beginning of the array? If it's a number, all right, we make a new array that's each of those characters. And then what if, just with JavaScript, we go through whatever this number ends up being, and we multiply each of the places by their place value. So you go, all right, first time through, it's times 1. Second time through, it's times 10. Second time through, it's times 100. So we do that with each of those things. We map it, transform these array of numbers to a new array with like their place values. And then we reduce those so we get the actual number. And then we keep going until we hit an operator. And then maybe we pass our first thing into the operator, and we wait for another thing to give it. So we keep going, do the exact same thing, build up some numbers, reduce them down, and that ends up being the second thing that we pass into the operator. And we take the result of that, and we just keep on going through the calculator. No eval. Pretty dope. Anything else? I don't know if I still have it. Might have gotten rid of it. Probably so. Maybe on my GitHub. Say I have one of these. Yeah, that one's pretty short. Not that much more shorter than the one I did. I have one of these that's crazy small. That one I don't think I pushed up my code. What about you? Yeah, that was probably about what we have also. I had one of these once that was like 11 lines. It didn't handle keyboard interaction, that kind of stuff, but lots of different ways to do this. Cool. Last chance. All right, survey's coming out.